Hello friends, welcome to this video, and this video is a continuation of my previous port binding shellcode part 1. So this is part 2. So if you haven't watched my part 1 video, then click on the I button in the corner and first watch this video, then continue with this video. So in my previous video I have write a simple C program about the bind shell, and then I just disassemble it and explain it to you all. So in this video I just write the same program in assembly and then get the hex OP code with the help of this shell script. This is this simple program, and then inject the shell code and test it. So let's create a simple assembly file. So we are going to write a whole lot of assembly code, and I just assume that you all know assembly. Without knowing assembly, you are just not going to do anything. So now start. Now we are going to just implement some function that we implemented in C. That is first the socket function, then bind it, then listen on that connection, then accept connection, and then duplicate the file descriptors and swapping them with the bin bash, that is a shell file descriptors. Okay, now let's first the socket. First storing all the register, that is clearing all register. EAX, let me copy this, EBX, ECX and EDX. Now I will change just their values, EBX, EBX, ECX, ECX and EDX. Now I have cleared all my registers, that is EAX, EBX, ECX and EDX. So now let's move the syscall value into the AL register, that is 0x66 value for the socket call. Now moving value in not BL register, you can say EBX, BX, it just doesn't matter. Here 01 is for the socket. Oh, spelling mistake. This. Now pushing the ECX, that is null. Now push byte 0x6, that is for IP PROTO, IP proto TCP. Now pushing byte 0x1, then pushing byte 0x2. So 0x1 for sock stream and 0x2 is for AF INET. Moving all these value into ECX register from the stack pointer. Now calling the interrupt 80. Now after the interrupt 80, when this syscall is executed, so we get the socket file descriptor into the EX register, and we know we are going to use the EX register in the next function. So we just move the value of socket file descriptor from EX register to ESI register. So now ESI register contain the file descriptor socket descriptor value. Sorry, it's socket descriptor, not file descriptor. Now second command, that is binding, moving AL with 0x66. This value remains same every time. The value changes, that is of BL 0x2 for the bind call. I do not need to write it now. Push EDX, that is null, pushing null. Push word. Here we push the word, not word, the port number 697A, 697A, that is port number 31337. Push word BX. Now moving the stack values into the ECX register, pushing byte 0x10. This is just pushing the last all the values in the structure struct socket ADR, in which we just make them null. So we just make them move this value into that, push ECX or in the next line. So we just move ECX on the stack, then the socket descriptor ESI. Now moving this again to ECX from ESP, that is stack pointer, the interrupt call. Now this bind command is completed. Now the next is listen command. Now moving again AL with 0x66, BL with 0x4, and pushing byte 0x1, and push the socket file descriptor. Now moving all this value into ECX register from the stack pointer. Now interrupt 80. Now this command is also complete. Now the accept command. Again move AL 0x66, BL 0x5, that is accept, pushing EDX, push again EDX, pushing ESI, that is socket file descriptor, moving this value to ECX register from stack pointer, the interrupt call. Now this is also finished. Now it's time for the duplicating the file descriptors and swapping them, which is just next to this function. Just moving EX, the value which is EX to EBX. EX contain the new socket file descriptor, which we move to EBX register, then clearing the ECX register. Now we'll just make CL value to 3, because here we need a loop, so that is only 3 times. So move CL 0x3. So DUP FT, first decrement the CL value, move AL with 0x3F, that is syscall number for dup2. Then interrupt call. Now JNE DUP FD, that is it should loop until the CL value becomes 0. So now the last function, that is EXECVE, that is the shell code, the shell, the bin bash shell, not a shell code. Now clearing the register, pushing EDX, pushing the 0x68732F6E, pushing again 6962F2F. So this stand for like HS /N, and this for IB /. So this whole is like /. Oh, I'm right, bin sh. I just got confused. Now moving EBX with ESP. So now ESP contain the address of the bin bash. Now push EDX, that is null, push EBX, that is the bin bash. Now move ECX ESP, push EDX, move EDX with ESP, move AL with 0xB. So let's check it again. just last thing left, interrupt, and now our code is complete. So let's check it. First we zor ex, clear the register, then we push edx, then this string in hexadecimal, that is 68732F6E. Next is 0x69622F2F. Moving ESP value to EBX, then pushing EDX, then EBX, and then moving EC stack pointer value to ECX, then pushing EDX, EDX, ESP, AL, 0XP, that is EX, ECVE, then interrupt call 80. Now it's completed. Let me just open a terminal and try to compile it. NASM format ELF32, because we are working in 32-bit registers. So 32-bit register, now ASM. So in line number 25 it says invalid combination of OP code and operand. And let's go to line number 25. So there is a mistake in line number 25, so it should be move, not push, I think, yeah. Because we can't push just like that, it should only be one register. So now it's correct. Now link it, MELF I386 and ASM object file, output should be ASM shell. So it's completed. Now let's try to run this ASM shell. So no error, no warning. Let me just use netcat to connect it. Localhost port number 31337. So it's also, I think, connected because it's not giving any. I just need to use bubble. So you can see our commands are working, pwd, so it's working. So we get a working shell, that is bind shell. So now we just need to get the hex op code, and for that we are going to use the get hex program. So now let's use the get and the name the file asm shell. So we got the shell code, that's our shell code. Now we just need to test it. And if you have watched my previous videos, that is remote shellcode testing, we have just made this program to test out remote shellcodes. So let me just copy my shellcode here. So this is simple Python program. We just copy the value of shellcode in this variable, then make connection on a specific port, then get connected, and then send the shellcode. So this is our launcher program. Let me open a terminal here also. Launcher. So segmentation fault, and I think it's not compiled successfully. Let me just compile it again. GCC FNO stack protector ZEXEC stack, and that is launcher dot c. Output should be launcher. So it's compiled. Launch. Oh, it should be. We should give it a port number. That is like if I get 8888. So now it's running. Let's see our code. So this program take two command line parameter. First is the IP address and second is the port number. So now let me first close those terminals which are not used now because of unnecessary. We do not need this. So open this Python demo. Address should be 127.0.0.1 and 8888. So we have sent it. So you can see we have sent a shellcode of length 108, and here it receives and shared and the segmentation fault code dumped. So I think my program is just a little bit faulty. Let's do it by just simple method. Just use a, that's what we call a simple shell file. Let me paste it here. So I just need to get the shellcode again from to the get hex. That is asm shell, copy it. I've copied it. Open the file, close this file, paste it. I just need to paste it whole. Already copied the back, so it should be here. Now let me just compile this shell file. Name is shell. Yes, it is shell. tcc fno stack protector, and I think it should also use the M32 switch. ZEXEC stack and shell dot c output should be shell. So it's working. Shell, I hope this now should work correctly. So it's running correctly. Now we just need to use our netcat localhost and then port number, that is 31337. Oh, another error. Oh, it's my mistake. Localhost, just use VB. So you can see connection to localhost succeeded. ls. So finally our shellcode works. So that's a huge success. Let's run some more commands. So you can see we have finally built a port binding shellcode. So that's so nice. So is there anything left? I think it's no. I think the my remote that is remote shellcode tester doesn't work because I just doesn't use the switch dash M32 because we are working with the 32-bit registers. So this, and my operating system is 64-bit, so I just need to take care of that. So now you can use this shellcode. Should exit. So we have got a shellcode, that is this hexadecimal opcode, and the benefit of it is that we do not, the CPU does not need to do anything with it. The CPU just execute it directly. So that's all for this video. Thank you. Have a nice day. So if you like this video, hit the like button, and if you have any query or feedback or any suggestion, then please comment below and subscribe to my channel for more videos. And here you can see a playlist of videos about shellcoding Linux. So if you want more videos on shellcoding on Linux, then watch these videos and subscribe to my channel. Thank you. Have a nice day.